So before I show you how to simplify rational expressions, I just want to state that it's very similar to simplifying fractions or putting fractions in lowest terms. So for example, if I have 12 over 15, you know that in lowest terms, this would be 4 over 5. And how do we get that really? Well, we think of a number that both 12 and 15 are divisible by, and they're both divisible by 3. 3 times 4 is 12, and 3 times 5 is 15. And then we divide out the 3's in our head, leaving us with 4 over 5. So that's how really we are simplifying fractions or putting fractions into lowest terms. The same applies here for rational expressions. You basically have to factor the numerators, denominators, and then divide out common factors. So let's look at the first example, simplify and state any restrictions on the variables. This is a very simplistic example. So you could find a common factor between 30x to the 4y cubed and negative 6x to the 7y and kind of write it like this. Or you can apply what you learned in the past. You've done something like this in grade 9 where you simply just kind of divide the numbers, which is the same as putting them in lowest terms. And that would give you negative 5. Or in lowest terms, you get negative 5 over 1, right? And then you're going to divide out the x's. So if we have 4 x's in the numerator and 4 in the denominator, sorry, 7 in the denominator, like so. The 4 from the numerator would cancel out with the 4 from the denominator, leaving us with 3 in the denominator. And then if we look at the y's, if we have 3 that are being multiplied in the numerator and just 1 in the denominator, the 1 from the denominator cancels out with 1 of them from the numerator, leaving us with y squared. Okay, so this would be the simplified form. Now we have to state the restrictions. We can never have 0 in the denominator because that would make the expression undefined. So x here can't be 0 because if it was, the entire denominator would be 0, and y can't be 0 for the same reason. So those would be the restrictions on the variables. And make sure you look at the original expression here, not after it's been simplified. Because in the simplified form, you have y that's missing. And at no time at all can we have a denominator of 0. Okay, so if you don't mention that y can't be 0, we're going to have a situation where it's undefined. Okay, let's look at part B. We have a function here. So first, before you start factoring this, we need to make sure that everything is written in descending degree order. So it's in the order that we're used to seeing. So the numerator is fine the way it is, but the denominator we have to rearrange. So the term negative 2x should appear first, followed by positive 2. Okay, now we can factor it so that we can eliminate common factors and simplify the particular function. Okay, the numerator, we can't take out a common factor, but I do recognize it as a simple trinomial, so I'm going to factor using product and sum. The product is negative 8 and the sum is 7. The two numbers that satisfy that product and sum will be 8 and negative 1. So the factored form is going to be x plus 8 and x minus 1. In the denominator, I can remove a common factor. The common factor is going to be negative 2. Negative because the first term starts with a negative. So you see, if you didn't rearrange this, to start, you wouldn't be factoring out the negative. And then you're going to be left with x minus 1. Now look for common factors. So x minus 1 is common to both numerator and denominator. We can cross them out, leaving us with this simplified form. Now the negative we usually put in the numerator or in front of the entire expression. So I'll just put it in front of the entire expression here. Now we need to state the restrictions. The factors can't be 0 because they will make the denominator 0. So x minus 1 here can't be 0. So if we set it equal to 0 and solve for x, that means x can't equal to 1. Since 1 take away 1 would make this 0, 0 times negative 2 would make the denominator 0. So we state that x can't equal to 1. because it will make the function undefined. Let's look at the next example here. Okay, everything is in descending degree order, so we can start factoring. From the numerator, it looks like I can remove a common factor of 3n squared, leaving me with n minus 1. From the denominator, it looks like it can remove a common factor of 4n, leaving me with 2n cubed minus 3n plus 1. Now I should check if I can factor, sorry, this is 3n squared. If I can factor the expression inside the brackets further. It doesn't appear to be a simple trinomial difference of squares or perfect squares, so I'm going to try to factor it using ratios somewhere on the side. So my product is 2 and my sum is negative 3, and the two numbers that satisfy that product and sum are negative 2 and negative 1. Writing the ratios using leading coefficient of 2, get 2 to negative 2 and 2 to negative 1. Putting them in those terms, get 1 to negative 1, and the second ratio will stay as is. It's already in those terms. So then my next line would be 3n squared times n minus 1 divided by 4n times n minus 1, once I add the variable n to the first number, and then 2n minus 1. Now I'm going to divide common factors. So I can see that I can cancel out n minus 1, but there's another factor I could cancel. One of the n's from the denominators cancels out with 1 from the numerator. So I'm left with 3n in the numerator, and the denominator will have 4 times 2n minus 1. So this is a simplified form. Now I have to state the restrictions. Look at the line before you simplified. Look at the denominator. There are factors here that we have to consider because they can be 0 for certain values of n. So if at this n is 0, the denominator will become 0. So that's our first restriction. Our second restriction is if this factor of n minus 1 is 0. That means n will be 1, making this 0. So n can't be 1 as well. And then this can't be 0. So I'm going to set it equal to 0 and then solve for n. So n can't be 1/2 because n is 1/2. Half of 2 is 1. 1 minus 1 makes this 0. 0 times the rest of the factors would make the denominator 0. So this is the simplified form, and these are the restrictions of what n cannot be. Okay, let's look at the last example here. We have the numerator 4x squared minus 16y squared. I can take out a common factor of 4 from the numerator. Oops. Okay. There isn't a common factor that I can remove in the denominator. Okay, but let's see if I can factor further. Let's look at the expression in the brackets. Okay, it appears to be a difference of squares. Two terms separated by subtraction. I can take the square roots of both. So square root of x squared is x, square root of 4y squared is 2y. I'll have two brackets, but they'll be opposite in sign because it's a difference of squares. How about the denominator? The denominator also looks like a special case. It looks like a simple trinomial because 1 is implied here. So I'm going to factor that using product and sum. The product is negative 6 and the sum is 1. So the two numbers that satisfy that product and sum are 3 and negative 2. So since the first term had x squared here, I'm going to start with x. And since the last term had a y squared, it will be followed by 3y. And the second factor will start with x and will be followed by negative 2y. Now that I've factored everything, I have to divide out common factors. So x minus 2y can be divided out, leaving me with the expression of 4 times x plus 2y divided by x plus 3y. Now I have to state the restrictions. Looking at the denominator from the previous line, these factors can't equal to 0 because once I multiply by a factor of 0, the denominator becomes 0. So let's set each factor equal to 0 and solve for either x or y. Now if you look at that expression, it's easier to get x by itself. So we're just going to solve for x. You don't have to do both. So we get an answer of negative 3y. So that's one value that x cannot be. And then we're going to set x minus 2y equal to 0. Solving for x gives us 2y. So x can't equal to 2y as well, because 2y minus 2y gives us 0, and negative 3y plus 3y gives us 0. Okay. If you do enough of these questions, you'll notice that you kind of have to, if your factor starts with a variable, then you just have to take the opposite sign of the term that follows when stating the restrictions. If nothing is being added or subtracted from your variable, so if your variable is by itself raised to some exponent, then that variable can't equal to 0 in the denominator.